Hello speaker systems! This video is to help you time align any fill speakers in your system bid number 3. You will have many fill speakers. Some of you will have a lot of fill speakers. And time alignment for fills is very important. Time alignment for subs, it's up for debate. Fills, pretty important. So this is a pretty simple drawing. This is actually from map assignment number 5. And I've got a front fill and I've got a main. And so I'm going to pick a spot to time align them, usually halfway through the coverage area. And we've talked about quite a lot in class, but we're going to pick the center front fill mic as our acoustic crossover. We're going to go over our processor settings and let me show you what's going on here. In your system bid, you're going to have probably lots of channels of mains and lots of channels of fills, and you can use multiple Galaxy processors. In this particular case, I've set a very simple main subs fill. We're not dealing with the subs right now, so I'm going to mute it. And we've got our fill on 3 and our mains on 1. And yours will be more complicated, but mine is simple because I'm making a video. Going to measurement view, let's just confirm we're looking at our same microphone, front of house center mic. Maybe we want some smoothing on to make ourselves feel better. I don't know. You can see the mains and fills are both on. If I go to express settings, I'm going to mute that fill and do a repredict. And now we can see that the mains are coming up pretty close to 0, and it looks like it's already set the propagation delay for me to that point, to that time. So I've time aligned. Great. Let's take a trace of this. Let's store this as our mains at FF because it's a front fill, and that'll be our first trace. And then we're going to turn on our fills and see what our fills do. So let's look at the fills. Please do a predict, and I'm going to turn on my front fill trace as well, and we can see them overlapping. So the first thing we see is that the front fill in this location, which is live and blue, is earlier, not a surprise, and quite a bit louder. I'm going to mess with the amplitude here a little bit here, and the amplitude viewing, and maybe put 20 dB here. And so and you can see that there's about 10 dB difference here. Of course, the speaker under the main hang is performing very strangely, but the fill, of course, is on axis. That's why we're using the fill. And so let's turn down the fill by 10 dB right away and see if it performs, if it will fill in the holes a little bit nicer. And I would buy that, like it's filling in the kind of holes in between. We probably want to high pass the fills, right? We don't need the hills. The fills are going to be subs and all kinds of stuff. Maybe we'll put a high pass in at 250. Let's try that. So I go over to the processor settings, and I'm going to go a little bit more gentle than a Linquist Riley 24. I don't really see the purpose of making it insane so I'll do a second order high pass filter. I'll put it at 250 hertz, turn her on. And now let's go back and look at our measurement view again and see what happens. And, now it's leaving room for the subs to do their thing. Is it hot? Is it loud? I don't know. Maybe it's a little hot still. So we'll bring it down -12. Depends on what kind of calibration scheme you want. I say a little bit extra front fill level isn't always a good idea to kind of cut through wedges and that sort of stuff. Now, time alignment is much simpler than it is with subs. We don't have to use the phase trace at all. We can just go over here and use this thing and get it done really quickly. I'm going to zoom in a little bit. You do have different increments. You can get pretty small in here. I'll stick with 140, go to milliseconds and move in, and that's too close. So let's move to 280 and give us a 28 millisecond window. Now I can really quickly slide my cursor over this, and it tells me that that's 18.8 milliseconds early. So I'm going to type that delay in and see what happens. So put in 19 milliseconds of delay, and it should overlap nicely. Now, we could spend more time dealing with microseconds, milliseconds, all that. In fact, I'm really ultimately trying to get those two numbers to match there, and they're really close. I could mess with the delay to get it more precise, but that would get that particular seat in alignment that measure might be like, but look, the true equal level, equal time is not occurring because we're underneath the array. If I did this example in the far field, for example, balcony speakers, or maybe you got the big EDM festival and you're dealing with far fills, this mains trace would probably look a lot nicer for you. It wouldn't be all wacky because you're right, this particular microphone's right underneath the array and weird things happen underneath the array. But you get the idea. Level time combined, kind of get your level up in the high end, specifically right around 4K at equal level. So in this situation, I am not doing that. I'm trying to fill this hole up. So I'm kind of, this is a bad video, right? I'm kind of losing level time combined. But you get the idea. The process is to get the level equal in that high frequency range and then mess with the delay, really using the system I just showed you over here with the impulse response, and all is good. If you have a problem with the video, I don't know, send a letter to the complaint department, okay? But I think it's probably good enough to give you the information you need. Let me know if you need more help. Bye-bye.